we just learned about the sampling distributions and performing z-score transformations with our sampling distributions. So now we're ready to actually calculate a couple probabilities. So let's start with an example. So the cost of fuel. So we are told that the average cost of fuel in May 2014 was $3.65 per gallon. So I'm going to say mu is equal to 3.65. So that the standard deviation of such cost is 15 cents. Okay, I'm going to write sigma is 0.15. Suppose that a random sample of n equals 100 gas stations is selected from the population. Okay, so n is equal to 100. And the cost per gallon of regular unleaded fuel is determined for each. Consider x bar, the sample mean cost per gallon. Okay, so part A, we want to calculate mu of x bar. Well, if we recall, this is just going to be equal to mu because we have an unbiased estimator. And so this is going to be 365. It was just given to us. But sigma x bar, we know, is sigma divided by the square root of n. So this would be 0.15 divided by the square root of 100. So that would be 0.15 divided by 10, which is 0.015. Okay, so we now have our mu of x bar and sigma of x bar. Now we're capable of performing z-score transformations. So what is the approximate probability that the sample has a mean fuel cost between 365 and 367? So part B. So the probability that we are between 365 x bar and 3.67. So I can now perform z-score transformation. So I have probability 365 minus our average, which is also 365. But now the key is that instead of dividing by 0.15, we're going to divide by 0.015. 0.015 is less than z, so we're going from x bar, which is the sample mean, so to z, and then 3.67. Get this a little bit out of the way. Minus 3.65 over 0.015. I'm running out of space here. Add a page. Okay, well this simplifies to probability that z is between 0 and 1.33. Okay, well, we know that z is centered on 0. We know that everything to the left and to the right of 0 is 0.5, so I know that this is 0.5. Then I have 1.33 here. So we're going to need to look up this value in our table. So if I look up, so here I have 1.33 for our z. So let me go down to 1.3. So 1.33. So 0.9082. Again, that's the area of this whole shaded region. 0.9082. So from here over is 0.9082. So that's the whole orange area. But I only want the blue area. So I can just subtract the two. So I'll take my 0.9082 minus 0.5, and I get 0.4082. Okay, let me clean this up just a little bit. So this is 0.4082, because the 0.5 plus the 0.4082 must be the 0.9082. Okay, part C, what is the approximate probability that the sample has a mean fuel cost that exceeds 3.67? Okay, so part C, probability that the sample has a mean fuel cost greater than 3.67. So X bar bigger than 3.67. Okay, well, we already performed the z-score transformation on 3.67, and we found it to be 1.33. So this would be equal to probability that z is bigger than 1.33. Again, that's just performing this transformation to get 1.33. Okay, so now we are interested in this area. Okay, well, we know that the total area needs to be 1, and we know that this blue area is equal to 0.9082. So I know that this will be equal to 1 minus the blue, 1 minus 0.9082 is equal to the orange area of 0.0918. So this is 0.0918. Or I could have also done this 1 minus 0.5 plus 0.4082. Those are equivalent. Okay, so we finished this problem. So let's do another. And as usual, I think it's best if you pause the video and attempt this on your own. So corporate sustainability of CPA firms. So we have support of senior managers have for corporate sustainability on a scale from 0 to 160. Higher point values indicate a higher level of support for sustainability. The study provided the following information on the distribution levels of support for sustainability. So we are told that mu is equal to 68, sigma is equal to 27, and we took a random sample of n equal to 30. Okay, so I have two problems here. It's the probability that x bar is bigger than 65, and then the probability x bar is between 65 and 70. So I would pause the video now and give it a shot. Okay, so as before, I'm going to start by finding mu x bar, which is just mu, which is going to be 68. And then I need to find sigma x bar, which is equal to sigma over square root n. So that would be 27 over square root of 30. So that comes out to 4.93. Okay, so probability x bar is bigger than 65. We're going to do our z transformation, so probability that z is bigger than 65 minus our average, 68, divided by our standard deviation of 4.93. So this is equal to the probability that z is bigger than 0 and negative 0.61. Okay, so this is centered on 0. Negative 0.61 is somewhere over here. And we want the area to the right of this value. So I want this area. Well, by symmetry, I can also think of this as the probability that z is less than 0.61. So if I wanted to redraw this, I could say that these areas are the same. And then I can follow similar logic as the last problem. So I know that this area is 0.5, so then I can look up the value 0.61 and then subtract the 2. So 0.61. So 0.61. So 0.61. Right, the 0.01. So 0.7291. So I get 0.7291. I didn't need to actually worry about this 50% here. We were fine to just look this value up directly from the table. So 0.7291. Okay, and then finally x bar between 65 and 70. So probability 65 minus our average of 68 divided by our standard deviation of 4.93 less than z less than, move this, 70 minus 68 over 4.93. This will simplify to probability between negative 0.61 and 0.41. Okay, so let's draw that. So put 0 in the middle. So negative 0.61 is over here. Then positive 0.41 is over here. And we want to find the area between these two values. Okay, so might need to be a little clever here. So we can look up this area in our table. So let's go ahead and do that. So let me just look up negative 0.61. So I'm going to use our first table because it's a negative value. So I have negative 0.61. So if I look that up, negative 0.61, right, 0.01. I get 0.2709. So this is 0.2709. Well, because I know that it's always 50% to the left of 0, I could say 0.5 minus 0.2709. This is always 0.5, just how it's always 0.5 to the right. It's going to be 0.2291. So this is 0.2291. Okay, and now for this area, we still need to find that. So I think I'm just going to look up the positive value, 0.41, and then I'll just subtract off our 0.5. So let me go to positive 0.41. So positive 0.41. So 0.41, I get 0.6591. So 0.6591, then minus 0.5 is equal to 0.1591. So this is 0.1591. And so to answer our final question, we can do 0.2291 plus 0.1591. And that comes out to 0.39.